Okay, so in the power series lab chapter, we know like if we have a function that is very difficult to do the integration, then we will turn it into a power series because it will make it more easy to do the integration. But today we are talking about the other way around. How do we find the power series and then we turn it into a function? Why do we need to do that? Because if you want to know the exact value of a function, is more precise than you use the power series, because power series is more like approximation, it's going to the infinity. But if you want to know the exact value, then it will be better that you find the function. So today we are going to turn a power series into a function. So today we are going to turn a power series into a function. So here is your power series. And how do we turn it into a function? Yeah, then we will learn by doing it. And at the end, it will be looking like this. This is your function, f of x. And you will be like, what? How to do it? So we are going to explain how to do it. Okay, so let's go to the next slide. So this is your power series. Let's take an observation here. Let me open a new layer. So first of all, as you can see here, it's n to the power of 2. It looks very serious because every time you took a derivative, so it will like move your power forward into your coefficient, right? So this look like it took 2 times derivative. Okay, so let me open this layer. Yeah, this looks very suspicious, and it looks like it has been taking two times derivative. So now let's think about what power series we know. So yeah, let's start from something that we already know. So this is the equation. Sorry, I mean like this is the power series that we know to turn a power series into a function. Then because of the questions look like it's taking 2 times derivative. So let's take derivative of this sentence. Okay. So after we took the first time derivative, it's looking like the purple line here because your denominator will be looking like to the power of -1. So when you do the derivative, it will be like to the power of -2. So you will put them in the denominator, which look like the purple line here. So after that, you took another derivative. So now you can see you took 2 times of the derivative, and then you get the blue function. I mean, like the blue power series equal to a function here, the last sentence, as you can see here. So let's see. Okay, at least now it's looking similar to the question. Okay, so let's go to the next slide. So basically, we just put everything we did here, the derivative that we did earlier, and we are going to use it later. Okay, here. Okay, so after this one, you took the second times derivative. Then I will write it over here. So now we're going to tidy up a little bit. So we times it into here and then here. And then it will become, let me move it down. Okay. So now it will be looking like this sentence over here. Why? Because I just take n into here and then also move this one into here. So it becomes this one over here on the other side of the equal mark. So let's take a look here. So this one is n, which looking like this one here. So how do we change it into something looking like this? You can see the difference here. Here n starts from the 1, here n starts from the 2, and here x is n minus 1, and here is x to the power of n minus 2, which then you will know to make it looking like this function, then you will, no, I mean like the other way. If you want to use this function to be looking like it here, then you will need to times 1 over x, right? Because then your power will become n minus 1. And then after that, the other difference is your n start from 1, but here your n start from 2, which means you need to minus your first category. Let's say it's s sub 1 here. So your s sub 1 should be, yeah, you just put a 1 into it. So it will be, okay, it will be 1x1 minus 2. So it will be 1 over x. So, okay, it's too messy here. I already wrote it on the right side. Yeah, as you can see here, you need to times x, 1 over x, and then you need to minus your first category. Then it will be looking like this if you put this value into here. Okay, so now let's keep going. So let's take a look first. As you can see here, now this one is very similar to your question, but it's still different. So how do we change it? Yeah, it's also the same. It's also the same concept. For example, here is to the nth power. Here is n minus 2 power, which is very simple. You just have to times x to the power of 2, so it will be x to the power of n. And now, as you can see here, n star from 2, here n star from 1. So very simple. You also need to minus your s sub 1, your first category. Then you will get this power series. Okay, so moving forward, it will be times x to the power of 2, x to the power of 2, and then you need to add your s1 because you're, oh yeah, sorry, I said it wrong because we n start from 2, but we want to start from 1, so actually it's plus, not minus. Okay, so now as we know, we already have this value, so we can put it in here. And also s1, you just simply have to plug 1 into n, which will be x. So very simple. It will be equals to your 1 minus x to the power of 3, and we put it in the denominator, and over it is 2. And then we plus 1 over 1 minus x to the power of 2 times 1 over x, and minus 1 over x and all of these to the power of 2 plus x. Okay, so this is the answer here, as you can see, this function. Yeah, and that's it.